Here is a matching type question. Study the items in both columns carefully. Try to work out the matching before we solve it together. Let us begin solving this step by step. Key concepts for SN2 reactivity: 1. Leaving group ability, IBrCl. 2. Nucleophile strength, stronger more reactive nucleophile increases rate. 3. Steric hindrance at the electrophilic carbon, less hindered is equal to faster SN2. Pair 1, n-propyl chloride plus now CH3 versus n-butyl bromide plus now CH3. Both are primary alkyl halides with the same nucleophile, now CH3. The difference is the leaving group. Br is a better leaving group than Cl because bromide is a weaker base, larger, more polarizable, better stabilized negative charge. Better leaving group is equal to faster SN2 rate. Therefore, 1-bromobutane, n-butyl bromide, reacts faster. Pair 2, n-butyl iodide plus O versus n-butyl iodide plus NaOH. Both substrates are identical, 1-iodobutane. The difference is the nucleophile base, O as a free ion, example, from KOH in solution presented as O versus NaOH. In this context, O anionic hydroxide presented directly is a stronger, more reactive nucleophile than NaOH used as a reagent in a less ionized or more buffered context. However, NaOH fully dissociates in water too, so the key distinction here is that O written explicitly represents the same species. The standard interpretation in MS Chauhan problems is that the anionic nucleophile O reacts faster than NaOH because O emphasizes the free, unassociated, stronger nucleophilic form. Therefore, 1-iodobutane, n-butyl iodide, with O reacts faster. Pair 3, neopentyl chloride, CH3, 3CCH to Cl, plus NaOH versus n-butyl chloride, 1-chlorobutane, plus NaOH. Same nucleophile and same leaving group. The difference is steric hindrance. Neopentyl chloride is a primary halide but has severe steric hindrance due to the 3 methyl groups on the beta carbon, making backside attack by the nucleophile extremely difficult. N-butyl chloride is a simple primary alkyl chloride with minimal steric hindrance. SN2 rate is greatly diminished by steric bulk, so n-butyl chloride, 1-chlorobutane, reacts much faster. Summary of faster reactions. Pair 1, 1-bromobutane, n-butyl bromide, better leaving group, BrCl. Pair 2, 1-iodobutane, n-butyl iodide, with O stronger nucleophile, free anion. Pair 3, 1-chlorobutane, n-butyl chloride, less steric hindrance than neopentyl chloride. Therefore, the correct answer is 1-1-bromobutane, n-butyl bromide, 2-1-iodobutane, n-butyl iodide, 3-1-chlorobutane, n-butyl chloride. Therefore, the correct matching is 1 matches 1-bromobutane, n-butyl bromide, 2 matches 1-iodobutane, n-butyl iodide, 3 matches 1-chlorobutane, n-butyl chloride.